Hi, welcome to Diagnosing Performance and Memory Issues in JavaScript-based Windows Store apps. It's 3:30 according to my watch. We're going to get started. My name is Andrew Hall. I'm a program manager on the Visual Studio Diagnostics team. We own the technologies like profiling, code analysis, debugging. So today, we're going to talk about the tools that are available for diagnosing performance and memory issues in Windows Store apps. Why do we care about perf? There's people in the room. I'm guessing you care about perf if you're here for this talk, right? The performance of an app is one of the first things that customers notice about your application. How many people who have a phone, have some sort of other tablet device, have ever gotten an app out of the store, first time you fire it up, it moves like a glacier, and you're like, I'm not using that again, and you're just kind of done with it. So performance is really important in this new world of an app store, because the odds are you're not the only app that does something functionality-wise to what you're doing. So you want to make sure that customers have a great experience with your app and that they're willing to keep coming back. Right? If you make multiple apps, people tend to start to recognize, oh, I really liked an app from this person. It ran great. It performed great. Or you say, oh, wow, the last two apps I got from this particular team or company or developer in the App Store weren't particularly good. I'm going to avoid their apps in the future. So we want to make sure that we build good ones. We're going to kind of go through this in about 4 sections. Real brief. I know I don't need to give you guys lessons on how to write performance, so I'm just going to have one slide on just sort of some good reminders, things that users care about when it comes to performance. Then we're going to talk about the basics of the Visual Studio Profiler. This is the JavaScript profiler that we shipped in Visual Studio 8 for Windows, and it's obviously anything that's in the Express SKU. Goes all the way up through the Ultimate SKUs. I'm going to be doing all of my demos from the Windows 8 Express SKU, so it's everything that you guys can get for free. Then we're going to talk about a tool called the HTML5 Performance Analyzer. I'm not sure how many people have seen that or have not seen it. It ships in the Windows SDK, which installs with Visual Studio, so it's on the machine if you have Visual Studio on the machine and are doing app development. It's a really good tool for assessing and telling you the things that you should care about at a high level when it comes to performance. And then the last thing we're going to talk about is the JavaScript Memory Profiler basics. JavaScript Memory Profiler is something that did not ship at RTM. It's not currently in your RTM bits of Visual Studio, but if anybody's seen that little notification pop up in the bottom that says an update is available to Visual Studio, if you go install that, that actually has what I'm going to show you today. So this is something we're shipping in a quarterly release to Visual Studio. The final one will come out in mid-November. But there's already, we're calling it CTPs for Community Technology Previews. And I can't remember if it's officially branded the release candidate or not. But basically, if you go install whatever update is advertising to you today that it has the bits that I'm going to show you today, because we haven't actually shipped the final ones of that. So a brief reminder on good performance practices. Right, responsiveness. This is one of the most important things that users care about. Don't block the UI thread. Human perception, people notice delays of more than about 100 milliseconds on the UI thread. So if you're going to do work on the UI thread, make sure that it happens really quickly. There's a lot of studies that show that things that take longer on the wall, users will rate as being more performant if when they interact with the app, it actually responds. Like they'd rather it run 250 milliseconds slower than not be able to sort of feel like the app is being responsive to them. So one of the things available to us in the new HTML5 world is break up your longer operations using things like set immediate, MS or request animation frame, or use web workers to do stuff on the background. In the new Windows 8 world, monitor your application's memory use. When users navigate away from your app, the OS is going to move that into a suspended state. I'm sure everybody who's been doing app development has notice that, right? You have to respond. You get these events that says, hey, you're about to be suspended. If you free up memory, when another application requests memory from the operating system, if it doesn't have enough, it goes and starts getting rid of apps that are already running. So once you're suspended, you might be re-enabled or you might just be killed. And the smaller your footprint, the less likely the OS is to actually take you out of memory. So the next time the user launches your app, or you start up a lot faster. And then the other thing that we've learned the hard way a lot of times inside Microsoft is if you want to write performant code, it's important to sort of, as you develop, to make sure that you're tuning and testing your performance regularly. A lot of times after small code changes, they introduce pretty big performance problems. If you don't catch them then, you then go build a bunch of other functionality built on top of that logic, and it becomes really, really hard to try to figure out how to change that without sort of introducing a bunch of churn in your code base later in the application's life cycle. So every time you sort of do stuff, just use the app, evaluate, make sure, and you have tools to sort of help you measure some of the stuff, which is what we're going to talk about today. So first thing I want to talk about is the JavaScript profiler that we ship in Windows 8 Express. How many people here have either used the profiler in the Windows 8 Express SKU of Visual Studio, or any Visual Studio SKU for developing JavaScript Windows Store apps, or have used the JavaScript profiler built into Internet Explorer? Okay, about a quarter of the people. So both of the profilers get the exact same data. They leverage the same hooks in the runtime. And they're instrumentation-based profiling. This means that they record exactly how long every method takes to execute, and they record exactly how many times each method is called. So you sort of have a lot of really rich data there that you can use. If you weren't expecting things to get called that frequently, that might be interesting. If you want to sort of think about what we just talked about, this is running on the UI thread, I want to evaluate how this is going to impact my frame rate, things like that. This will tell you exactly, this took 120 milliseconds, or this took 16 milliseconds. So you don't have to just rely on your gut feel. You have a very objective tool that will give you absolute measurements. Now, one of the downsides, to be honest, we don't think it's the end-all, be-all of performance profilers. It does only show you JavaScript execution time, right? It does not show you work that is done by other systems in the Internet Explorer sort of realm. So if you manipulate style in your JavaScript code, that might execute very quickly, and then the browser has to go do a bunch of work to change the style layouts, right? We're not going to show you that. So there are certainly expensive things that can occur that you can cause with your JavaScript that we're not going to be able to record with this profiler. So one of the things, just two pieces of terminology that are sort of very important in the profiler that a lot of times people have a hard time when they first see them understanding what that means. And we have two terms when we talk about the amount of time a function executed, and that is the inclusive time and the exclusive time. So inclusive time is the total amount of time from when the function was entered until the function executed. Right? It's pretty simple. Like, it doesn't matter if you spent all of your time in 3 children down the call stack, or if you spent all of your time in your own function body. It is just the total amount of time that from the time you were called to the time that you returned. The exclusive time as a function is the amount of time executing code just spent in the function body. And this does not include time spent in child functions. So it's just executing, arithmetic operations or whatever else you're doing in your code where you're not calling into other APIs or other functions in your code. So a little illustration just to help what this looks like. I have two functions. I have alpha and beta. Right? So alpha is going to execute for 30 milliseconds. This little script block is its own source code. And then alpha is going to call beta. Right? Beta is going to execute for 50 milliseconds. So does anybody know what the exclusive time of alpha and beta is going to be? Exclusive time of alpha is going to be 50 milliseconds. Because how much time it's been executing its script code without any function calls. And the inclusive time of beta is also going to be 50 milliseconds because it didn't call anything. Now for alpha, the exclusive time is the 30 milliseconds we spent executing the function body. And then the inclusive time is the 30 milliseconds executing the function body plus the 50 milliseconds executing beta that it spent in the call to beta. So, all right, so we're going to switch over and let's take a look at this profiler. Oh, whoops, wrong button. OK, so I have Visual Studio up. Can the people in the back see that OK, or do I need to make it a little bigger? I see a thumbs up, no thumbs down. OK, perfect. So my scenario is I have an app. I'm just going to go ahead and do a Control F5, so launch without debugging. Show you what it does. It's nothing amazing yet. It's a navigation app. I can click here. It takes me to a picture of a pond. I can navigate back. Not that exciting. So I just want to point out, I did launch it without debugging. This may be obvious, but in the Windows 8 world, you don't want to, or especially JavaScript world, you never want to evaluate performance. It doesn't matter what your application type, but JavaScript is exceptionally true of this with the debug build. Because you don't want to profile inefficiencies in sort of things that might get optimized away from the experience that the customer would have. And in the JavaScript world, does anybody know the difference between if I'm debugging and not debugging in JavaScript? Right? It's interpreting the code when I'm running the application with the debugger attached, whereas it jits the code when I'm running an application without a debugger attached. So the performance gains can be orders of magnitude difference with jitted code versus interpreted code. So a scenario is you saw the app, I kind of click over to a pond, and I want to, when I click on that pond, I want some nice water ripples to appear. Kind of a nice little simple app. This is my first app. I'm learning how to build an experience, and so there happens to be a woman on my team who is really good with this type of stuff in terms of image manipulation. And I heard that she had some code that would do this. So I sent her an email and said, "Hey, I heard you had some code that would do some water ripples on an HTML canvas." And she sent it to me, and she said, sure. She was just playing around with some ideas. She hasn't really performance tested it, but what she was doing seemed pretty good. So she attached a file that I've already downloaded that was pool.js. And so I'm going to go ahead back to and then she gave me just a little snippet of code telling me to add it to my initialization logic for wherever I want to use the canvas. So I'm going to go back to my application. And what I want to do is my pond page is the one that is currently controlling the logic once I navigate there. So I'm going to add an existing item. I'm going to go to my downloads, and I'm going to add the file that she gave me. OK, it's there. Let's go to my pond.html. I've already added the pool.js, so you can see that it's going to get loaded into the page. And then I just need to go, for formatting purposes, I've already pasted into Visual Studio because the browser adds extra spaces. So I'm going to go add this to my initialization logic in my pond.js file. So I have my init. I put my image on the canvas when I load it. And I'm just going to go ahead and paste this in there. And so what this is going to do is I'm picking up her code, and we're going to see how it performs when we go evaluate it. So I'm going to go ahead and give it a Control F5. Launch without debugging. Everything so good. So far, so good. I navigate over. OK. That's not great. Not bad in terms of performance. Question is, could I make it better? And when I navigate back, the other thing I want to point out is that kind of felt a little bit slower, right? I was on the page. I'm not sure I'm in love with how fast that appears, right? Everybody see the kind of the ripples up in this area. Definitely can be a little faster. And when I navigate back, it seems that my navigation back is a lot slower. So let's go use the Visual Studio Profiler. Now, so it's available right from the debug menu. One thing I'm going to talk about today is I think this is great functionality, is the Start Performance Analysis Paused. What this does, and I'll go ahead and click it because it definitely does improve or increase the startup time of your application a little bit because the JavaScript runtime instruments all of the sort of function calls as they're jitted. And so you're going to see it's going to start up slower. And it is going to impact the performance of my application a little bit because every time we call a function or return from a function, you're recording that, right? So it's not free to record that data. So I'm going to go ahead. So you don't really want to evaluate the performance with a profiler attached, but the profiler will help you accurately measure how long things are taking. So I'm going to go ahead. I'm going to navigate to my pond. I'm going to click that. I have some water ripples going. Oh, I forgot to unpause it, right? So the reason I started paused is the scenario that I want to profile is my water ripples, right? I don't necessarily need data for the application starting up and things like that I have to filter through. So I'm going to go ahead and click Resume. I'm going to go back to my app. Ripples are gone. Let's click this. It's going to do some ripples. That's probably enough. Navigate back and stop profiling. So now it's going to take a little bit. It was collecting a data file. It kind of has to go finish that collection, merge the file, do some analysis. You can see the output window is actually what's kind of showing me what's going on right here. So it's telling me profiling is finished. So now we're analyzing the report. Depending on how much data you collect, this can be really fast or really slow, every function you called. Now, as you're going to see here, actually in that little bit of time, the way this code was written, as the profiler is going to show me, it called an insane number of functions. So the thing about instrumentation data is not predictable in terms of how big of a file that it will generate, right? So if any of you have ever dealt with like a sampling-based profiler where you just like record CPU call stacks or something and like on an interval, every couple milliseconds or every millisecond or so, that is a very predictable, in this amount of time, worst case scenario, you will get a file this big. For instrumentation-based profiling, because it records every function call, you could run for an hour and get 0 data if the code is sitting there idle, or you could run for 1 minute and end up with a 40 gigabyte log file. That actually happened to someone on my team. So go ahead and put the output window back over here, because I think it stays nicely out of the way when we start doing things like launch it. So I'm going to go ahead and use a view now that I think is really useful, and this is built into Visual Studio, and that is full screen view. So it makes all the other windows go away. So if you're ever sort of working in the IDE, it's just a little tip and trick in Visual Studio. If this works for source code, you can see I can navigate between my source files as well, but it made all of the tool windows go away. So it's just kind of a little trick that you can do. So this is the code that I got from Eleanor, who's a member of my team, to do. And we saw the RIPL. So this is a summary page of the profiler. And the first thing you notice is it's going to tell me what my hot path was. The hot path is based on some analysis while I was sitting here talking, and you saw a little spinner saying we're analyzing the report. It was crunching a bunch of numbers for me to try to help me identify what was executing most frequently, kind of what is the call stack that's responsible for this problem. Now, this is a relatively simple app, and you'll see that actually 100% of my inclusive time was taken in my hot path, and almost 100% of my exclusive time is between two different functions, this function called RIPL and this function called math.floor. That's a native function built in. I'm guessing most people in this room who have done JavaScript development have done it. And then below, what the second half of this is I have a summary table that's telling me the individual functions doing the most work. So the top one is the call stack that was doing the most work, and then this bottom one is the functions with the most exclusive time. And it so happens in this case that both the ones on my hot path and the ones doing the most individual work happen to be the same. But obviously the case is not always the case. So let's go ahead and take a look at RIPL. I'm just going to click. So I'll start by clicking on math.floor, and it's going to jump me to a view called the function details view. Now, in this particular case, I'm going to click back in 1 second. What this is showing me is a butterfly view of the world. Right? The middle one is the function that I'm looking at. So I clicked on math.floor, and I have no source code for it because it's a native built into the runtime. So if I click on RIPL, now I navigate back, and it actually shows me, jumps me right to the source code for RIPL. So I know that she's using math.floor. I'm going to click on this and open the real editor. The editor you were seeing there is a read-only. And I know a little trick that I think I can improve the performance. Instead of using math.floor, because it does a bunch of security checks, I know that she's giving me numbers. So I don't have to worry about sort of all these security checks to make sure that I'm not trying to round a string or whatever. So I'm going to copy and paste so you don't have to watch me type, because nobody really wants to do that. But I'll show you what I did in a second. I'm going to use basically a 0 bit shift. So let's go ahead and make sure we got all of them. So I'm going to do a find in the editor, and I'm going to search for math.floor, and I'm going to say take me to the next. And you can see that what I've done is instead of using math.floor, I've commented here. I basically have just done a bit shift of 0. It's not going to change the value of the number, but it's going to force it to turn into an integer instead of instead of being a float that it could potentially be. So let's make sure I got them all. Math.floor, math.floor, math.floor. OK, I've got all of them. So let's go ahead and fire it up again. Control F5. Or sorry, I'll go ahead in this way. Debug. Start without debugging. And let's go. And yeah, it definitely runs a lot faster, because with just a little bit of work, I eliminated approximately 40% of the time that I was spending every time I did that. So go ahead and close that. Let's go back to Visual Studio. And so the other thing that I wanted, which I talked about before, was, oops, sorry, I didn't mean to close that, is I thought that the navigation back was a little bit slow, but I didn't profile that. So what we need to do is go ahead and start paused. It's going to launch my application. And I just want to show a couple other views of how to use some of the other stuff. So I'm going to come back. I'm going to click on that. I'm going to go back. I'm going to resume. And now I'm going to navigate back. And let's see why navigation back was so slow. This one's going to be a lot quicker. And so the first thing I'm going to notice is, I think by the time I went back, my ripples were mostly done. Yet in my navigation, let me toggle full screen. We have a shortcut for that right on the summary profiler summary page. Everything's showing up there. Is that, okay, ripple, well, I did click, so let's go look at ripple. It's possible that not really much work was happening, but if it's slow. So I'm going to jump to the call tree view. And we have a little shortcut here to expand the hop path. And so the first thing I want to point out is the column headers actually work correctly if you have a normal font size, but is that it shows me the exact number of times that ripple was called. So I clicked, did some water ripples, I navigated back, I unpaused, I went back, and 50 seems like a high number of times for ripple to have been called. So I wonder if there's any other place that, what's going on? And so if I go to pond.js, this is the initialization code that she gave me. I see that ripple gets called here when I first load the page. And then pool.js, let me scroll over, that she's actually just continually calling herself with the request animation frame. So that's why my count's so high in theory. Once I navigate to that page, I'm always going to be doing all of this bit processing, even if I don't need to be doing any bit processing. So I guess I would ask, why do I need to be doing that if I'm not actually animating anything? So let's go ahead and make one more change, and let's just say just when I click, let's wait to start the animation until there. And I'm going to actually do this a little bit more elegantly by adding some callback logic. So I'm going to record, instead of just doing a straight starting the ripple here, I'm going to go into my pool.js, and I'll show you what I did in just a second. Because I'm a good programmer, I'm going to be efficient about these things, and I'm going to record the callback for the request animation frame, because I don't want every time it clicks to start competing request animation frames. So now I record the callback when an animation frame is called, and then now down here, only when the user clicks, if there's no existing callback, because I'm going to be manipulating bits, do I actually want to start rippling my water. So let's go ahead and debug. Start without debugging. Let's just evaluate the performance. Boom. And it's pretty snappy. So pretty quickly we were able to pick up some code. I'm sure no one here has ever reused or copied and pasted code from anybody before. And basically identified a couple problems with it that as we copied and pasted it in, we were able to, with tools in, 5 minutes or 15 minutes, to identify some problems and make sure we fix that as we go forward. So next thing I want to talk about is this performance analyzer for HTML5 apps. Has anybody used this tool that ships in the SDK? I don't see any hands. Wow. So it basically pops up a dialog. We're going to look at it right after this. This is the only slide I'm going to make you look at for this, I promise. And it walks you through testing your application. It's going to say, step 1, do this. Step 2, do this. Step 3, do this. And then when you're done, it's going to generate a report measuring these 13 different tenets of performance. Activation time, it's going to tell you how quickly, whether you met guidelines set by the Windows team for what their goal should be for activation. It's going to tell you if at any point your UI was unresponsive. It's going to talk about layout. Some of the things I talked about, the profiler we just looked at, can't show you. Right? Did you make synchronous requests? Are you scaling images? How is your memory footprint on the application? Are you leaking memory? How did you handle the suspend state? What does your memory trend look like? And so it's not going to show you anything live, but it's going to give you this great report, and it only takes about, depending on if you really exercise all the functionality, which I promise I won't make you watch me do the whole thing, but it only takes about, they say 15 minutes max if you do all of the stuff that they care about, and they're going to make sure that you behave correctly. And I think it's really, really worth using the tool. So let's go ahead back. The next slide was just said demo, so I didn't think you needed to look at that. So I'm going to open up. I'm going to show you this 1 second. So what this is right here is this is where the tool is. It's not incredibly intuitive to find. I was involved with this team as they were building the tool. I knew that it shipped in the SDK, and I had to send them an email saying, hey guys, where is this tool? So, and that's because it's under Program Files, Windows Kits, 8.0, bin, pick the architecture that matches your operating system architecture. It doesn't matter what architecture your application is, and then @perf analyzer. And when I went looking for it, I basically had stopped at the Windows Kits 8.0. Question here.
So it should make sure you're talking about the Windows SDK, not some other SDK.
Yes, so the question was, am I talking about the Windows SDK? Yes, this is the Windows 8 SDK. That is correct, which you can either install independently, or if you install Visual Studio on a Windows 8 machine, it gets installed. So I'm going to go ahead and get out of this mode. Just wanted to make sure everybody saw where it was. And the slides, which will be available after this for download, there's a link at the end. So I'm going to launch @perf analyzer js.exe. It's going to ask me for elevation. You'll notice that most of our tools at this point now are asking for elevation. Sometimes people ask why that is. We're building most of these tools on top of what's called an ETW, or event tracing for Windows, which is built into the operating system. It lets you get a lot of really great data. But the operating system in the 8.0, at least in Windows 8 and previous versions, has a hard-coded requirement for elevation. So it's not possible to build a tool and get that data. So I'm going to pick the app that I want to analyze, My Pond. This is the app that we're playing. And let's get started. So it's going to give me a list of things to do and don't do. All right, we don't need to read that right now. And so now it's going to tell me to get the app ready for analysis. All this really wants me to do is get it warm. So it tells you to play with it for 30 seconds. I don't know why the refresh rate on here is not good. I don't know what app it is. We'll work around it like that. So it says use the app for 30 seconds. I don't really think I need to do that. And then close it. So I'm going to use the close gesture. I'm going to go back here. I'll say I'm done. All they really want you to do is make sure the code gets loaded into memory, so you aren't sort of testing like the truly cold scenario. If you have, this happens to have an SSD, but they want to make sure that the modules are in memory and stuff like that. So the first time you're not basically profiling sort of an exceptional case where Internet Explorer isn't up in memory and stuff like that. So I didn't use it for 2 to 3 minutes. You don't need to watch me play with it for 2 to 3 minutes. It's not that interesting of an application yet. So I'm going to say I'm done. Take me to the next step. So now it actually starts a timer, and now it's really recording data. So it says launch the app, wait 60 seconds, return here, wait 15 seconds. So I don't know why it's doing this. I think it's a display thing, but so I'm going to launch it. It says wait 60 seconds. I don't really think you want to watch me wait for 60 seconds. So we're going to return here. And it wants me to wait 15 seconds. The reason it wants me to wait 15 seconds is it wants to make sure that the application gets suspended. So I just opened Task Manager, or I would have if I pressed the right key combination. And I'm going to go to my details, and they just want to basically make sure that it gets suspended. So I'm going to watch my WWA host. It's already suspended. I don't need to wait the full 15 seconds. I'm done. Take me to the next step. So it says step 2 of 6, but you only have to do these things on step 2 through 4. So now it wants me to switch to the app, snap the app, wait, unsnap, return here. So it's still running. That's good. Now, I didn't actually bake any snap functionality in here yet. I'm still early in development, so I'm a failure. But it says wait 60 seconds. You can imagine that I'm waiting 60 seconds, unsnap the app. The reason they want you to wait for 60 seconds is because on the slides that I showed you before, I'm going to go back here and click I'm done. I'm going to wait till it gets suspended again, is they want to look for things like memory leaks and stuff like that. And since JavaScript is a garbage collected runtime, there's sort of no guarantee that like the second you make a change, even if you freed a bunch of memory or changed a bunch of memory stuff, that a garbage collection was going to occur. So I'm suspended. I'm going to say done. Take me to the next step. All right, switch to the app, perform a common task, return here, wait 15 seconds. This is actually the one that sort of interesting to talk about, so I am going to use it for the full 60 seconds because at the report time, you don't, it will yell at you and tell you that it wasn't able to determine a bunch of things if you haven't really used it for a full 60 seconds. So I'm just going to navigate around. Navigate back. I'm watching my timer up here. Okay, should be good enough. All right, wait 15 seconds. They want to make sure it gets suspended. It's suspended, so we can go ahead and say I'm done, take me to the next step. I didn't actually use it for a full 60 seconds, but that's okay. So now it's going to save the trace. It's going to build the report. While you're watching the report build, I know that's not exciting. Any questions so far? No questions so far. All right, perfect. So it's going to tell me. Can everybody see what it's analyzing right now? As it's going, it's kind of telling me that it's, analyzing app launch. It's analyzing data for app snap. The next one's going to be analyzing data for typical usage scenario. And then as soon as it's done with that, that was steps 2, 3, and 4. It's going to tell me that we're going to spit out the report for me. Yes?
Tap remotely to say, like, to remote debug the session data from ARM tablet, for example. Is that a use case?
So the question was, if you attach remotely on an ARM-based tablet, is this a use case scenario? They don't have remote debugger integration with this tool, but what they did have is in the bin directory, there is an ARM drop or an x86, and so you would put that on a thumb drive and run it that way.
I missed that, sorry.
Oh, that's okay. I didn't really. I kind of glossed over that. So, is that clear? So there's not the nice kind of F5 experience that you get in Visual Studio. But put it on a thumb drive, bring it over, launch it, you can generate the report. And because I didn't do it on my, okay, so it's done. But because I didn't do it on an ARM tablet, you'll actually see in the report it's going to yell at me, because one of the things they want you to do is to evaluate it on typical hardware. So generated a report. I can say, okay, I'm going to double click this. It's going to open an Internet Explorer. And it's going to tell me that I failed 5 different scenarios. Can everybody kind of see that? We'll go ahead and zoom in a little bit here. So this is sort of the list of assessments. I passed 20, I got warned on 7, and I failed 5. So of the ones I failed, that's probably where I want to start looking. Correct hardware. Okay, I know, it's a demo. You guys don't want to watch me put things on a thumb drive. Okay, I'll get to that later. Image scaling. That's interesting. Image scaling and memory footprint. So 3 out of my 5 were completely unrelated to stuff that, to the fact that I wasn't using my hardware. So let me go ahead and click on the image scaling. And I think the zoom is throwing this off a little bit. And so basically what it's going to tell me, let me see if I can do, instead of zoom, settings, let's do this. Is that good enough for people to see in the back? Can you kind of see what's going on? Okay, perfect. So what it's going to tell me is it's going to tell me that my pawns scaled 4 images, and at least one was from the apps package. So it's going to tell me the name of the files. It's going to tell me that I scaled Pebbles, Tropical Reef, Koi Pond, JPEG. These are the ones that when we first load it up, we think about these are the pictures that we're showing. So that may be something I want to go think about addressing at some point, right? It is used perf resources, a lot of CPU work to scale an image. And it tells me how big, right? It tells me the original size of the image was 1280 by 800, but it was actually rendered to 150. So that's a pretty wasteful scenario. So let's go ahead and back up to the top. And then same image scaling again. No surprise, it's effectively going to warn me of the same issue. And then the last one I want to look at is this memory footprint, right? And so it's going to tell me I failed. Apps run better when they use a small amount of memory. An app should have a memory footprint of less than 60 megabytes. To reduce your app's memory, blah, blah, blah. My pond reference set is 118, and the working set is 146. This exceeds the 80 megabyte reference set maximum that they set in the guidelines for this tool. Okay, I want to go look at my memory. which works out well because that's what we're going to talk about next. So, JavaScript Memory Profiler. Has anybody had the opportunity to play with this yet or even heard about the fact that this exists? Okay, a couple people raised their hand. So this is something, as I mentioned, that's going to be shipped in a quarterly update to Visual Studio. If you have Visual Studio installed today, you should be seeing a little toast pop up saying updates are available. And the goals are we really want to help people identify unintentionally retained memory and inefficient use of memory. So we're going to kind of talk about those two scenarios here when we start playing with the tool. The JavaScript memory tool is a snapshot-based tool. That means that as you use the tool, you click Take Snapshot, suspends the application, goes and dumps all the memory in JavaScript and the DOM elements, tells you how big they are, what the reference graph is, and then the application continues running. So it's not sort of a continuously recording thing, but I can take snapshots at different points in time. I can compare them. I can see how things have changed over time. But it's not the same as sort of the instrumentation profile where I'm constantly recording things. I have to sort of, as a user, choose to do action. It shows JavaScript and DOM elements, how big they are, the counts, and the reference graph. So what's keeping them alive in memory because it's the garbage collected runtime. So just like we talked about for the profiler, we tend to find that we have gotten a lot of questions so far about two pieces of terminology in the tool. Size is actually pretty intuitive. That's not the one we get questions about. But how large is the object in memory? And retained size. And retained size is the amount of memory that the object is preventing the garbage collector from reclaiming, which includes the size of the object. It includes the size of all referenced objects and any objects that happen to be below them if the current object is the only parent of in the memory graph. So I think an illustration will probably help best with that. So this is my reference graph. I just happen to have 4 objects in memory. Object A and object C are my roots. Object B and object D are parented by those roots. A has a reference to B and D, and C just has a reference to D. So the sizes should be pretty intuitive. That's just the size that's up in that actual slide. Does anybody tell me what the retained size of A is going to be? I heard 700. So the retained size of A is going to be 600. And the reason it's going to be 600 is because if I free A, it will get garbage collected. And because nobody else holds a reference to B, B will also be garbage collected by virtue of freeing A. But because C holds a reference to D, even if I free A, D is still going to remain in memory. And so the retained size of B is simply going to be obviously its size because it doesn't reference anybody else. C is 50. Now, if I were to free A, so A and B got garbage collected, then the retained size of C would actually go to 150, right? Because it would now be the only parent of D. And then D is obviously 100. So any questions on that? Does that make sense? So the question was, why is C 50 for the retained size? So C is 50 for the retained size because A also holds a reference to D. So even if I collect C, D is still going to be held alive in memory by object A. Is that a question in the back or just stretching? Just stretching. Yes.
Is there a helper mechanism as part of the tool or anything that will say that, oh, by the way, D has 2 owners?
So the question was, is there a helper mechanism that's part of the tool that will say that D has 2 owners? Kind of. So perfect timing. Thank you for the nice setup. You can collect your fee after. So we're going to go back to our machine. And I can go ahead and close Visual Studio at this point. So the answer to your question, as I'm bringing up the tool, is it shows you the full reference graph. So if only one person has a parent to you, then you would only have one person referencing you in the reference graph. Unfortunately, the way the JavaScript runtime works, as I think you'll see, I didn't try to design a demo to hide the reality of the tool from you. Like a lot of times, even if there's only sort of one thing that actually has a reference to you, the JavaScript runtime will like basically show multiple references. So let's go ahead and launch our JavaScript memory analysis tool. So once you install the quarterly update to Visual Studio, it's just going to appear right here on the debug menu, right below the start performance analysis ones that we used earlier. And I'm going to choose to launch my startup project. I could also launch a installed app package, or if it happens to be running, so I'm using my app, I notice that, oh wow, the memory's gotten really big, I'm writing a media player. So if anybody played with their Surface yet, have you played with the video or music player in the Surface? So the team that wrote that, they ran into a problem that after watching a movie for like 45 minutes, all of a sudden the memory would be huge. They didn't really want to have to deal with, well, I need to go relaunch it and then run it for 45 minutes until I get back to the problem. So we have the ability to attach. I'll actually, for the purposes of this, go ahead and launch installed app package. It's going to show me the list of ones that are installed. I know that I have my pond. This is the one we just did. So I'm going to go ahead and select that. And why are you? Go ahead and say launch. And so, if you want to use this, for example, on a machine and you don't have the original project for some reason, you can do that. You can actually even go play with the apps that ship in the Windows Store and tell Microsoft how good they're doing. So first thing, I'm going to go back and you can say here, sorry, there's a little bit of cropping on the graph with how big I've made my font size here. But my private bytes is 47.3 megabytes. And I'm going to take a snapshot. Because remember, the tool was telling me that my private bytes were much larger than that, but I've been using the app for a while. So what I want to do is I want to get a baseline. And I see that it's 11.88 megabytes here in my heap. Well, my first thought is, if I'm really pushing up against an 80 megabyte, all my app is doing is this. Why am I using 11 megabytes for the JavaScript and DOM objects? That's a good question. So I'm going to go ahead and go in here and inspect it. There's a couple different views. The default view, for anybody who's familiar with, anybody here use the Chrome development tools for web development? I heard a no, yeah. So the dominators view, this is going to sort by the retained size first. So, let me go ahead and do this view. Toggle full screen. I have no idea why. Fonts. View. Okay, there we go. This should help with the column widths. So it's going to start off by sorting by retained size. That's why we talked about what retained size is. And I'm going to see that, well, global, okay, that's not particularly interesting. Focus, well, that's basically image. So now I have image. Okay, well, I have a 3.91 megabyte image, 3.72 megabyte image, I have a 3 megabyte image. Remember the tool we just ran, the HTML Performance Analyzer? Oh, that's right, I had image scaling issues. So I'm actually, for the purposes of showing these three things, wasting almost 10 megabytes of memory in a world where I've been recommended to stay below 80 megabytes of memory. That seems like a pretty big waste. So let's go ahead in here. Let's kill this and stop. And what I want to do is, instead of just loading up my the images, you can see right here I'm just doing image, document, create element, set the source. Well, what if I use the thumbnail functionality built into Windows 8? Let's see if that makes an improvement to our memory. So I'm going to go over here to my little snippets so you don't have to watch me type. And control. Go ahead and copy and paste this. I'm going to replace my item promise code here. And all I'm going to do, I didn't sort of nicely organize it, but you can see all I have done here, let me go ahead back to this view, is instead of setting the source to be the URL for the one that I'm going to use, because I kind of wrote this app, I know how it works, the one I'm going to put on the canvas, I want the full-size image to put on the canvas, right? It's big, we click, we want ripples over the pond. But I don't need that for this little navigation thing that I'm going to show. So I'm going to use the get file from application, and then I'm going to use the new get thumbnail that's built into Windows 8. So it's just going to return a thumbnail image to me, I'm pretty sure. Let's see if this improved our memory. So let's go ahead and save that. Let's go ahead and now launch our startup project, because the one currently deployed on disk is not. Let's go back. It actually seemed to start a little faster too, if I may say so myself. And I can see that my heap is 32 megabytes. Yeah, sorry about the cropping again. And let's go ahead and take a heap snapshot. Sorry, this is my private bytes, is 30. And it went up a little bit, but I'm at 1.64 megabytes instead of the 11.5 that I was at there. So, one snapshot, glance at the tool, I already identified a way to save myself some memory because I know the size of the DOM elements that I'm using. So let's go evaluate now how our memory, because we have a baseline snapshot of what things look like in this world. Let's see how memory neutral, because remember it also told me that my memory was increasing in my HTML5 performance analyzer, and it was what, like 150 megabytes or something. Let's go use the app. Okay. Typical usage scenario. Let's come back. Went up, didn't come back down. I'm going to point out one other thing, and I'll show you how to do this in code right now. We also have functionality in here. It's called write mark. And so I instrumented my code, and I'll show you how I did that, to emit an event, and I can put whatever string I want. So whenever I navigate to a page, I say, and it said navigate to Pebbles, because I clicked on Pebbles. So let's go ahead and take a snapshot. Let's see if maybe that. And I see that just by virtue of navigating to the page and navigating back, my memory didn't go down, and in fact, I increased it by 16 megabytes. That's a pretty big increase in application. So let's go see. If I click on either of these two red lines down here, it's going to jump me into the diff view automatically. So this is going to remove all of the objects when I'm looking in the list that existed in both snapshots. So all the stuff that was created in my application startup, all the sort of Win.js references I have and stuff like that, those are going to be sort of removed so I have a nice view of the world. And it's going to tell me what changed. Well, global, okay, that's not useful. Right, Ripple, 12 megabytes. Okay, well, Ripple, we know before when we were performance profiling, this is the code that I picked up from Eleanor on my team, and it's what's manipulating the canvas. But I don't use that code when I'm back on my start page. So I'm obviously leaking Ripple. So why am I leaking Ripple? And this answers the question that the gentleman in the front row asked. And so once I select this, I have my reference graph down here. And it's going to show me everybody that's holding a reference to that. So the first thing that I see is I have a callback that's holding me alive. This is sort of a pretty common pattern that when we're talking to people, event handlers also fall in the same category of why are things alive in memory. So I'm going, yeah, you know what? I was adding a request animation frame callback to this, and I don't think I ever cancel it when I navigate away from the page. And then if I start digging through here, it's going to tell me, well, Ripple has a reference to itself, which has a reference to drop, which drops a function inside pool. Okay, so that's not really, so, okay, so, sometimes there's another callback reference. Let's go remove the callback and see how life has improved, or if it hasn't improved at all. So I'm going to go ahead and stop. So now, I'm going to go back to this. And so what I want to do is I'm going to go back to my pool.js, and I will apologize because I copied and pasted the code. It would not be in the style guidelines recommended by sort of Windows app development. But in my pool.js function, what I want to do is I want to add a cancel. So I'm going to go control. I'm going to paste that, right? Makes sense. And now in my pond.js, I'm going to go in my event that unload, respond to navigation event from this page. I'm going to say water.cancel. So I'm going to go, oh, okay, you know what? I actually create this variable down here. This is the code that I picked up from Eleanor. So let's go ahead and let's actually move the scope up. Let's put water up here. VAR image, say VAR water. Okay, and now we can actually reference it from when we navigate away from the page. Water dot cancel. Okay. So now go run the memory tool. Let's see how life has changed. And you'll notice as I'm sort of doing this, all of my sessions are getting created. So the performance reports that I took are in a performance reports folder over in Solution Explorer. And sorry, this is really really small. Let me float this for a second to show you what I'm talking about. And then we're calling these diagnostic sessions for the memory tool, and those are being placed in the diagnostic session folder. So if later I actually make a change, and I go, you know what, how big was the heap before when I was doing that? I can go back and pull all those old ones up. Let's go ahead. I canceled the callback. Let's launch my startup project. All right, let's go take a snapshot just to make sure. Always nice to get a good baseline. Navigate. Ripple, let's get a couple ripples, make sure we get a lot of callbacks going. Navigate back. Okay, my didn't come down. I thought I improved things. You know, I don't know if anybody has ever done a lot of memory investigations. We've had this problem in Visual Studio. Memory investigations are by nature very tricky to get right. So I should always use a tool. And effectively, my heap diff was 16 megabytes. What was it last time? Let me look. It was like 16.06 megabytes. So I'm going to go, and it's probably effectively the same. It's probably just noise in the system. Why not? So I didn't really improve anything. So let's go back here. Let's go back to my identifiers, dominators. And what was my problem last time? It was pool. Well, pool is still here. There's some other stuff that's kind of showed up. This anonymous function, which is, this is the enclosing scope for, if I click here, you can kind of, this will help describe what it is. And I can see that this has a reference to water, image, and init. So this is the closing scope for water is now sticking around, and it's actually big because water is big, right? Water's what's holding the reference to pool. So let's go see if we can find water. And okay, let's go back to pool. Let's see what's keeping pool alive then. Let's go ahead and drag up the this. Sorry, I forgot to do this. My apologies. And I can see that the only thing holding references to pool now is it says it's pool. And this is what I was saying. I didn't design a demo to actually hide the way the tool works. Drop that water. What's keeping water alive? So water is being kept alive by anonymous function. So update layout, unload. Okay, I cancel it and unload, but I don't use it. I don't use it in ready. And init, load event handler. Aha. I know what the problem is. Now that I move the scope up, let's go back. Stop. Go pond.js. I actually either need to get rid of all my references or null it out. So let's go ahead one more time. Oh, whoops. It's okay. I forgot to take a snapshot. I can see that my heap is indeed smaller. Let's come back. See how that compares. Well, it got kilobytes bigger. It didn't get megabytes bigger, so I think I probably fixed that. And let's see if we have a pool in here. And I don't have pool in memory anymore. So by using the reference graph, I was able to fix my leak. So we have about 7 minutes left. That time was probably, so let's switch back here. Any questions before we kind of move on? Yes, sir.
So we're using this to debug the Windows 8 desktop app. Can we do any of this stuff with browser-based?
So the question was, we're using this stuff to do Windows 8 desktop apps. Will this work in the browser-based world? The answer is not with the first quarterly release. I can tell you it is definitely on the plans to make it work against Internet Explorer, but we sort of had to prioritize for, we only had about 3 months to get sort of this tool out the door for the first quarterly release, so we chose to focus on the store apps. Because of the way the WinJS libraries work, that was sort of perceived as the bigger pain point because it's really easy to sort of leak memory. So in summary, sorry.
So just to clarify that, so all of the things we looked at were just desktop?
So the question was, are all the things we looked at just desktop apps? The answer is yes. Everything I have showed today is specifically targeted at Windows Store applications. That is correct at this point in time. So kind of in closing, install the quarterly update number 1. You're going to get the memory tool that I just showed you. And then, as we kind of talked about, using tools as I make changes to make sure that I don't get an app that's really bad. Use the tools you already have to improve the performance of your app. The 3 that we talked about today, sort of the big 3 that we have available at the moment for Windows Store JavaScript applications on the desktop. Certainly something we look to improve in the future. So are there any questions? I saw your hand first, sir.
So are these tools unmutable? So can you add it to TPTs or not?
So the question was if these tools were automatable. The profiler that I showed you there is a command line version. It's just vsperf.exe, which is if you open up so I'll switch back here real quick, just a developer command prompt administratively in VS. I don't know why this is not displaying correctly up there, but it's vsperf.exe. It's available from the developer. All right, so vsperf, and you have to run it elevated. But the memory tool is not automatable from the command line at this point in time, unfortunately, because it sort of does a couple multi-process interaction that the IDE coordinates. And the HTML5 performance analyzer that we looked at is also not automatable because of sort of it's very UI driven, at least to my knowledge. You had a question here?
I did, yeah. So on one of the tools you showed us, there was an 80 megabyte memory limit. Will your fail Windows Store validation if it goes over that?
Okay, so the question was, in one of the tools, it said there's an 80 megabyte limit. Will your app fail validation if it goes over that? I'm not on the Windows App Certification team, but I believe the answer is no. That was a guidance that they set. So anybody writing Windows Store JavaScript apps, you notice that it runs inside wwahost.exe. If you look at it in Task Manager in the details pane, that was based on sort of a lot of research of working with people that was perceived as sort of being a good citizen of the system. But I do not believe that you will fail certification if you go over that. That's just sort of their guidance. Like if you're over this, think about if you can be more efficient. Yes, sir.
For the WinJS apps, is there a performance difference for project configuration of debug or release? Not debugging, but if you're,
Got it. So the question was, for JavaScript applications, is there a performance difference in a debug versus release project configuration? Not for the JavaScript code. If you have C++ libraries underneath or managed libraries that you're going to reference, then yes, that setting will affect the compiled languages. But JavaScript is very binary in its optimizations. Either when you launch it, you have a debugger attached and it goes interpreted, or you don't have a debugger attached and it is going to JIT and optimize to the best of its ability. So, any question over here? Yes.
Yeah. What other scenarios would you use the XPerf tool for that aren't covered by these?
Okay, so the question was, what other scenarios would you use the XPerf tool that I did not cover here? So XPerf, they have JavaScript call stacks. If you do a CPU sampling based thing, I can give you my card afterwards. You can actually collect that data with the profiler that we ship if you just want a single process view of the world, because we do collect the same data, but we just didn't have time to implement the call stack. XPerf, so from a JavaScript perspective, purely focused on JavaScript, that's effectively the one thing that they bring is the CPU sampling. They'll show you your JavaScript code sort of in line with your native and or managed call stacks. So if you're calling like native, or if you just want to do CPU sampling, you can see from a CPU sampling perspective how your JavaScript is using. If you want to step back from the JavaScript view of the world and start thinking about native and managed, they also, well, I guess in terms of sort of overall system impact, they will show you things like context switches and disk use. Context switches, anything that you can get a call stack for, your JavaScript code will be showed as part of that call stack. So if you're doing something in your JavaScript code that's resulting in a lot of context switches, you can view that in the XPerf tool. Sort of any place that you could think of collecting a call stack for an event, they will also just sort of, if you do the right flags, light up your JavaScript code as part of that call stack. Their big thing is that they sort of do a system-wide trace, and you can sort of, not real time, but stacked, see correlation between sort of disk and context switches and CPU use and network use. So does that answer? Any other questions? I think we are about out of time. My timer is telling me that I have 1 minute. So 2 related sessions, said slides, I don't know, building high performance JavaScript for modern engines. And then there was a talk on modern JavaScript. I don't know what time these talks are, but they exist if you're interested. Or I believe both of these are both. because they're very focused on the JavaScript language, which in the Windows 8 world, whether you're writing a desktop app or browser-based app, it's the same JavaScript engine. And so these are focused on the capabilities of JavaScript engine. Yes, sir?
I didn't see any sessions on TypeScript. Is there one?
There was one on TypeScript with Anders Heilsberg.
Is that tomorrow?
It's tomorrow.
Oh, thanks.
So the question was, I didn't see any sessions on TypeScript, and there is one tomorrow. I don't have the session code. So go download the slides. I have links to all of the tools. I also have links to 2 performance talks that were given by the WWA host team at last year's Build conference. Please submit the session eval. I'm sure this isn't your first session. You either have a Windows 8 app or you can do it online. Thank you.